Hello and welcome to today's maths lesson. My name is Robert and it's great to be here. It's great to be able to do this. It's great to be able to bring learning to you. In today's maths lesson, we're going to continue talking about analytical geometry and we're going to be talking about tangents and angles. And so let's get straight into it. If you guys turn to the board with me, today we're going to be talking about tangents. We're going to be talking about angles, but before we do that, we're going to talk about lines because, in essence, a tangent is a line. It's just a special sort of line. And so we're going to recap what a line is. A line, like we discussed in previous lessons, has got the equation mx plus c. Y equals mx plus c, where m is the gradient and c is the y-intercept, the y-cut, where the line cuts the y-axis. And so what we're going to do now is we're going to do an example of a question with a line and with a circle and see how that plays out, because what we're going to have to do is we're going to have to use some of the circle geometry that we learned in geometry to be able to solve this question. And so let's get to it. Our question says there's a circle, x squared plus y squared equals 10. In this case, because it's not x minus 1 squared, minus 1 would have moved my circle to the right 1 unit. In this case, it's just x squared. And so that means the center of my circle is at x equals 0 and y equals 0, which is the center there in my Cartesian plane, the origin. And they tell me that there's a chord drawn, AB. They tell me that the point D is the midpoint of my chord, and that's important. We're going to see why that's important later. And what they want us to do is they want us to calculate the equation of this line AB. Now, I'm going to move the sketch to the top of the board there so we have a little bit more space to work. We've discussed this quite a few times, but when it says determine the equation of something, a parabola, a line, a hyperbola, a circle, I'm always going to start by writing my standard form. That standard form is y equals mx plus c. What do I need to find? I need to find the gradients, and I need to find the y-cut. Now, it's very apparent that from this sketch, I can't see the y-cut, so probably what I'm going to do is I'm going to calculate the gradient, and then I'm going to sub in the point to calculate or to determine what the y-cut is. All right. Now, I still don't have an idea about how to do this. I need to work out the gradient of this line. Once I know what the gradient is, I can sub in the point. But how do I calculate the gradient of that line? It looks like it's just a random line. This is where we're going to have to remember our circle geometry and specifically this theorem. Now, this theorem here says that if we have a circle on the left here, and there's a line from the center of the circle, and there's a chord, and the line from the center of the circle cuts that chord in half. What that means is that the line from the center is perpendicular to the chord. Now, let's see how that's going to help us with this question. So let's go back to the question. What we've known, what the question told us is that that is the midpoint of this line. If I draw a line from the center of the circle to the and I don't know what quite happened there. If I draw a line from the center of the circle to the center of the midpoint, what I know is that this line is perpendicular. Now this is great because I don't know if you guys remember, but we spoke about perpendicular lines in a previous lesson. If I can work out what the gradient of the line from the center is, then I can work out what the equation of line AB is, because those are perpendicular lines, and then I can go from there. So the gradient formula is this. We discussed that in previous lessons. I want to work out the equation of the red line, which is from that point to the center of the circle there, which is 0, 0. And so what did we decide? I'm going to go y minus y, so I'm going to go that y value minus this y value, minus 1 minus 0. I'm going to go that x value minus this x value, minus 2 minus 0. I'm going to put that into my calculator, and you guys can trust me on this. The answer is equal to 1 over 2. Now, what have I done? I've gone and worked out the equation, and let me just erase a little bit here. Oh. It's shifted to the other side. All right, that's perfect. I'm going to pick it up on this side. I'm going to erase that there a little bit just so I have a little bit more space and change the color of my pen. I've gone and calculated the gradient of that line as a half. Now, this gradient of line AB, we decided because it's perpendicular lines, the product of the gradient is always going to be minus 1. But what did we decide we were going to do in the previous lesson is all I'm going to do is I'm going to take the gradient of the one line, I'm going to flip it over, I'm going to change the sign, and that's going to be the gradient of the line that's perpendicular. So the gradient of line AB is going to be this gradient flipped over. So it's going to be, instead of 1 over 2, it's going to be 2 over 1. And I'm going to change the sign to a negative, because a negative times a positive is going to give me a negative answer. Now I want the answer, my product must be equal to negative 1. And so, excellent. Now I have my gradient, minus 2x. All that remains for me to calculate is what is the y-cut. But remember when we did this in previous lessons, what we discussed is that the whole idea, and let me choose my eraser here, the whole idea about functions is it's all about input and the resulting output. And so if minus 2 is the input, minus 1 is going to be the output, and so that's what I'm going to do. I'm going to put in minus 2, I'm going to get out minus 1. Let me do that in red. So y is minus 1, x is minus 2. Let me go back to blue. And now all I'm going to do is I'm going to solve for c. I'm going to simplify a little bit, so negative 2 times negative 2 is 4. I'm going to subtract 4 on both sides, and if I do that, I get c is equal to minus 5. Excellent. And so my equation ends up being minus 2x minus 5. So let's move on to the next part of this question. We can see I have the equation of my line, and it asks me what are the x-coordinates of A and what are the x-coordinates of B. So here I have my circle, here I have my line, and actually what they are asking is what are the intersection points of my line and my circle. So remember, when we did intersection points, we had to solve simultaneously. And so the way that we're going to solve simultaneously is there I have y, here I have y, but y is equal to this. And so I'm going to take this whole section and I'm going to sub it into y. If I do that, I'm going to get x squared plus y squared, but now y is equal to minus 2x minus 5, and so I'm going to go and put, instead of going y squared, I'm going to go minus 2x minus 5 squared. This is equal to 10, and this gives me an equation where I can solve for x. Again, what's crucial is when we do something like this, I write this out twice. So this is not 4x squared plus 25. I'm going to write this out twice, and then I'm going to do the distribution of multiplication, which we've called FOIL in the past. I'm going to get x squared plus 4x squared plus 10x plus 10x plus 25 is equal to 10. And I'm going to collect like terms, so there I'm going to get 5x squared. That's going to give me plus 20x I'm going to take that 10 to the other side, and I'm going to get plus 15 is equal to 0. And I'm going to leave the question there. You guys can solve it on your own at home now in the ad break that's to come. I want you guys to solve for me what are the x values for A and for B. So we're going to go to an ad break now, and we'll see you guys soon. Welcome back from the ad break. Before the ad break, we spoke about lines, but what we're going to do is now we're going to talk about tangents, because a tangent is a line and it's a special sort of line. And so what we're going to do is we're going to talk about tangents which are linked to circles. So if we go to the next slide, a tangent, which you would have gone through in geometry, is a straight line that touches the circumference of a circle at only one place. And so this here, the red line, is not a tangent because it touches my circle there and it touches my circle there. Line AB is a tangent because it only touches my circle at point. It only touches my circle once. And so that is a tangent. Now, what's important to remember about tangents, and we're going back to our circle geometry, is that a tangent is always going to be perpendicular to a radius. So if I draw a radius from the center of the circle to the point where the tangent touches the line, that one point where the tangent touches the line, the tangent and the radius are going to be perpendicular. Now, let's jump into our first question. Our first question says, determine the equation of the tangent. Here I can see my tangent in red. To the circle, x squared plus y squared equals 25. So the center of the circle is at the origin, at the point t, 3, 4. So they want me to calculate the tangent at that point. So when we're talking about an equation, it's a line, and so it's going to be mx plus c. So what I need to calculate is the gradient and the y-cut. The y-cut is going to be here somewhere, but I can't do that by inspection, and I can't do the gradients with 2 points because there aren't 2 points. So how am I going to do this? We're going to do this using what we just discussed about circles, tangents, and radiuses, or radii actually, is that a radius is perpendicular to a tangent. And so I can't work out the gradient of the tangent to start with, but I can go and I can calculate the gradient of the radius. If I have the gradient of the radius, then I can go and calculate the gradient of the line. And so let's do that. The gradient of the tangent, the radius from 0, 0, the center, 2, 3, 4. How did we calculate that? Well, I went the y value minus the y value over the x value minus the x value. So let's go y value 4 minus y value 0 over x value 3 minus x value 0. And I get gradients of the radius equal to 4 over 3. Now, because I have the gradient of the radius is perpendicular to the tangent, and we discussed that when lines are perpendicular, it means the product of their gradients is equal to -1. But what we decided is what we can do to find the other gradient is I can just flip over my gradient and change the sign. And so the gradient of my tangent is just going to be, I flip over 4 over 3, I get 3 over 4, and I change the sign from a positive to a negative, and the gradient of my tangent is going to be negative 3 over 4. And so what I know is my gradient. I still need to go find my y cut. How do I do that? By subbing in a point. And so I'm going to take this point and I'm going to sub it into my gradient. I'm going to take the y value, put it into y. I'm going to take the x value of 3 and put it into 3. And all I need to do is simplify this equation. This equation isn't nice. So what I'm going to do is I'm going to take out my calculator to make sure that I get this right. I'm going to go, and I'm going to go minus 3 over 4 times 3 on my calculator, and I'm going to get minus 9 over 4. I'm going to add 9 over 4 on both sides so that I can solve for c. And I'm going to do that on my calculator. So let me take out my calculator. I'm going to go 4 plus 9 over 4. And this is going to give me 25 over 4. And so I know that my y cut is 25 over 4. My gradient is negative 3 over 4. And so the equation of my line is minus 3 over 4x plus 25 over 4. So to recap, what do? I work out the gradient of my radius. Then I flip it over and change the sign so that I can calculate the gradient of my tangent. And then I sub in the points so that I can then calculate my y cut. Excellent. So let's move on to the next question. The next question, they say, determine the equations of the tangents to the circle given that both lines are parallel to that line. I think the ordering of my slides is mixed up, and so I'm going to move to this question, and then I'm going to come back to that question that was on the previous slide. So let's do this question. It says, determine the equation of the tangent to the circle at this point. Now, this question is a little bit different from the previous question, because in the previous question, I knew where the center was. The center was at the origin. Now, I don't know where the center is, and so it's going to be a little bit tougher for me to calculate the gradient of the radius, right? So what I need to start with is I need to first find the center of the circle. Once I have that, then I can calculate the gradient of my radius and move forward from there. Now, we discussed this when we spoke about circles, all right? But what I'm going to have to do here is I'm going to have to complete the square. So I'm going to write it in a different order. I'm going to put the x's together. I'm going to put the y's together. And I'm going to go and complete the square. Why am I completing the square? So that I can get it in standard form, so that I can know where the center of the circle is, because once I have that, I can work out the gradient of my radius. So what did we decide to complete the square? Is I'm going to take the coefficient of x, divide it by 2, square it, and I'm going to add it. But I always have to add it on both sides. That's important. So 6 over 2 is 3. 3 squared is 9. And so I'm going to have to add that 9 on both sides. Then for the y, I'm going to take the coefficient of y. I'm going to divide it by 2. I'm going to square it, and I'm going to add it. Sorry, divide it by 2 rather, not 1. So 2 divided by 2 is 1. 1 squared is 1. I'm going to add that on both sides. And what I end up with is x squared plus 6x plus 9 plus y squared minus 2y plus 1 is equal to 7 plus 9 is 16 plus 1 is 17. All right. Now I'm going to go factorize both of these, because once I've factorized it, I know what the center of the circle is. And so let's do that. I'm going to get x plus 3 squared. I'm going to get y minus 1 squared is equal to 17. And this is great, because now I've got it in standard form and I can see what the center of the circle is. This plus 3 has shifted it in the opposite direction, shifted it to the left, and so my center is going to be at minus 3. This has shifted it up, and so my y value is is going to be 1. That's the center of my circle. And this is excellent because now that I have the center of the circle, minus 3 and 1, I can work out the gradients of my radius. So I'm just going to erase everything on my board so that I have a little bit more space to work with. I'm going to remember the center of my circle, minus 3 and 1. So the center of my circle is minus 3 and 1. Excellent. Now I know that, I can go work out the gradients of my radius. This was the center. Let me just, oh, that's not very nice. Let me just write it as a C. Excellent. My gradient was y squared minus y1, y2 minus y1 over x2 minus x1, which is going to be y minus y at the top, 5 minus 1, over x minus 2 minus x. And again, whenever I do a substitution of a negative number, I'm always going to do that in a bracket. At the top, I'm going to get 4. And at the bottom, I'm going to get minus 2 minus minus 3 is minus 2 plus 3, which is going to be 1. And so I get a gradient. This is of my radius, which is 4 over 1. That's excellent, because once I have the gradients of the radius, I can work out the gradius of the tangent. The gradius of the tangent, because it's perpendicular, I'm just going to flip it over and change the sign. And so my gradient of my tangent is going to be, flip this over, 1 over 4, and I'm going to change the sign to a negative. Once I have that, I can sub in the point. Well, the only point that I have is this point here, which is minus 2 over 5. I'm going to sub that in. So y is 5, x is minus 2. I'm going to get 5 is equal to, I'm going to do that on my calculator to make sure that it's right. That's equal to a half plus c. I'm going to subtract a half on both sides. I'm going to get c is equal to 4,5. Excellent. I have my gradients, I have my y-cuts, and I'm left with minus a quarter x plus 4,5, and that there is my y-cut. Welcome back from the ad break. We spoke about tangents and lines, and now we're going to be talking about angles. So turn to the board with me and we'll get right into it. So the angle of inclination, and this is a fancy word that we're often going to be using, always refers to the angle between a line. So here I can see, let me choose red. Here we can see a line, all right? Here I can see the positive x-axis, and the angle between them is always going to be the angle of inclination. Now what's important is the angle, and you can see where the arrow is there on my angle. The arrow is in an anti-clockwise direction. And so it's always going to be measured from the x-axis towards the line in an anti-clockwise direction. It doesn't matter if the line is going up or the line is going down. I'm always going to measure that angle in an anti-clockwise direction. And we can obviously see that the angle is going to be different when the gradient is different, right? So if the gradient is steeper or flatter or going up or going down, that angle is going to be different. And we're going to be talking about how do we find that angle. So if we go to the next slide, we're going to be talking about the formula. This is the last formula in analytical geometry that we're going to be talking about to find that angle. I'm going to derive it, but if what I say in the next 2 minutes doesn't make sense, it doesn't matter. I'm going to get to the formula, and that formula is the important part. That formula is what you need to remember, because that formula is what we're going to be using. Okay? So to get the angle of inclination, the gradient, which we decided is going to affect that angle, is always calculated by going, how much has the y changed? So the y value, how much has the y value changed over how much has the x value changed? And so if I look at this line here, and I were to look at this point at the bottom here, and I would look at the point top there, and those were the 2 points that were given to me, how would I calculate the gradient? Well, I would see how much is the y changed by, and so that triangle is delta, and that just means change. So the change in y, how much is the y value changed, and how much has the x value changed, and I'm just going to go and divide those two, and that's going to give me my gradient. Now, but I don't know if you guys can remember this, but if I go and draw a right-angled triangle, and I want to go calculate, or I draw in that angle, what do I know about that angle? Is that tan of that angle is always going to be the opposite side divided by the adjacent side. And so tan of this blue angle is going to be the change in y over the change in x. So the gradient was the change in y over the change in x, and tan is equal to the change in y and change in x, and that's our formula. Our formula is going to be tan theta, tan of the angle is going to be equal to the gradient, and we're going to be going from the gradient to the angle, and the angle to the gradient. So let's do some examples, and let's see how that works. So our first example, it says, determine the gradient of a line with an angle of inclination of 60 degrees. So they want me to calculate the gradient, m, of this line. Now the formula will be given to you. The formula will always be on the formula sheet. And like we've discussed, for analytical geometry, for every question, I want you to go look at the formula sheet and decide which formula am I going to use, because it's always going to be some formula. And in this case, the formula that I'm going to be using is tan of my angle is equal to my gradient. In this case, I know what the angle is. The angle is 60, and so I'm going to go put that angle into my formula. Let's do that. Tan of 60 is equal to m. Awesome. So now I can work out my gradient by using my calculator. So let's go to my calculator, and let's go tan of 60. And this is equal to, oh, sorry, and let's go back. I went back a slide there. Tan of 60, I calculated this. This is equal to the square root of 3. Is that a nice gradient? No, it isn't, but it is a gradient. Wonderful. All right. Now, let's go to the next question. The next question, they say, determine the angle of inclination of the line y equals 2x minus 1. So again, we're talking about the angle of inclination. And so what does that mean? I'm going to be using this angle, this formula, tan theta equals m. And this question is different because in the previous question, they wanted the gradient and they gave us the angle. Now they want the angle. Have they given us the gradient though? Well, yes, because what do I know about a straight line? Is that number that I'm going to multiply x by is my gradient. And so I know that my gradient is equal to 2. And I need to go find the angle, all right? So we've done this when we did trigonometry. But if I want to solve for this equation, all I need to do is I need to go theta is equal to, and then on my calculator, I'm going to go shift tan of 2. And so I'm going to write that down here, but I don't want you guys to write this down for yourselves. This is just so that we can see what to do on the calculator. In your test, well, you're welcome to write it down, but in your test, just do it and write down the answer. So let's go back to our calculator. What am I going to do? I'm going to go shift at the top here. I'm going to press tan. I'm going to put in 2. I'm going to close the brackets, and I'm going to get an angle. Oh, and let's go back here. What was that angle? That angle was 63,43. So I'm going to get an angle which is 63,43 degrees. And so I know what that angle is. I started on the previous question with the angle and I went to the gradient. Now we're just going backwards. Awesome. All right. So let's look at the next question. The next question is it's exactly the same question as the first question we did, except in this question, the line is going down. All right. So they still want us to find the gradient. And so I'm going to use this formula, tan theta is equal to m. I know the angle is 120. All right. What do I expect the gradient to be, though? The gradient of this line, the line is going down, so the gradient must be negative. If it's not negative, we've somehow made a mistake. And so just be careful with that. Here, let's go back. I can go tan of 120. If I do that, I get a gradient of negative square root of 3. That's exactly what I expected. I expected my gradient to be going down. Excellent. And so I'm going to do this question again. This is determine the angle of inclination. Now they want us to find the angle. But in this question, there's going to be a little bit of a change. And so don't tune out of this question just because we've done this very similar question. Listen carefully because there's a little bit of a twist in this question. All right, so they want me to find the angle of inclination. So I'm going to start with the formula, tan theta is equal to m. All right, I know what the gradient is. Like in the previous question, the gradient is negative 2. And so what I'm going to go do is I'm going to go work backwards, and on my calculator, I'm going to use shift tan of 2. So let's go do that. I'm going to, let me clear. I'm going to go shift tan. Oh, sorry, messed that up. Shift tan of negative 2. And the answer that I get is negative 63,43. Now, a negative angle, does this angle here, theta, look like a negative angle? No. It looks something along the lines of like more than 90, less than 180. So, yeah. Now, how are we going to work back to that angle? Now, I'm not going to spend a lot of time on this, but tan is a periodic graph. And so tan, the answers of tan are going to keep repeating themselves because of the shape of tan. And so all we're going to do is whenever you get a negative angle, all I want you guys to do is just add 180. That's all. So if you get a negative angle, just add 180. And if I do that, let me go back to my calculator. I'm going to take that negative 63,43. Negative 63,43, and all I'm going to do, let me go back here, sorry, is I'm going to add 180, and if I do that, I get 116,57, and that feels right. A negative angle didn't. So whenever you get a negative angle, what do? I add 180 and I get my angle. We're going to go to an and break now. Think about this and we'll see you guys soon. Welcome back. We're going to continue talking about that angle of inclination. What did we say was the angle of inclination? It was the angle between the x-axis and the line, always in an anti-clockwise direction. Now, we're going to jump into the next question. The next question says, determine the angle of inclination. They want us to find that angle of this line. Now, how did I calculate the angle of inclination? I use the formula tan theta is equal to m. So what do I need? For this question, I need the gradient, all right? But before I can calculate what the gradient is, I need to have my graph, my straight line graph, in standard form. If it's not in standard form, then I can't decide what the gradient is. And so my standard form is always going to be y equals mx plus c. What do I need to do? All I need to do is I need to get y alone on one side. Currently, the x is on the same side as the y, and so I'm going to take it to the other side. I'm going to add x on both sides, and I'm going to get x plus 6. Then the y is still not alone. There's a 2 with it, and so I'm going to divide both sides by 2, and I'm going to get y is equal to a half x plus 3. Wonderful. Now that I have y alone, I can decide the number that I'm multiplying x by, that half, is my gradient. And this is great, because once I have my gradient, I can go and calculate the angle of inclination. And so let's do that. Tan theta is equal to a half. Tan theta is equal to my gradient. And how did we decide we were going to do this? Well, we were going to shift tan. We were going to do that on our calculator, shift tan of a half. And so let's go to our calculator. I'm going to go shift tan of 1 over 2, close my brackets, and what am I going to get? I'm going to get 26,565, so I'm going to round up there, 26,57. I'm going to get theta is equal to 26,57 degrees. The angle between my line and the x-axis in an anti-clockwise direction is 26,57. Wonderful. Let's turn to our next question. Our next question says, determine the angle of inclination of the line that passes through the points -4 and 1, 2, and 5. Again, all I'm ever going to do when we're doing analytical geometry is I'm always going to use a formula. So turn to the formula sheet. You've got 4 formulas. You've got the distance formula, you've got the midpoint formula, you've got the gradient formula, and you've got the angle of inclination formula, tan theta equals m. Which one am I going to use here? Well, they want me to determine the angle of inclination, and so I'm going to use this formula, tan theta equals m. But to use that formula, I need the gradient. Exactly like we did in the previous question, I need the gradient. And so here, how am I going to calculate the gradient? Well, I'm going to use the gradient formula. And so my gradient formula is y2 minus y1 over x2 minus x1. What is that? Well, let's go do that. I'm going to go y minus y, 5 minus 1. Again, this is where we need to be careful. I'm not subtracting 1. I'm subtracting -1. And so it's so easy to just write 5 minus 1. It's not. It's going to end up being 5 plus 1. And so whenever you substitute a negative value, always make sure that you do it in brackets. At the bottom, I'm going to get 2 minus 4. This ends up being 6 over 6, which is equal to a gradient of 1. Wonderful. Now that I have my gradient, I can sub it in, and I can work backwards to calculate theta. Now, when we've spoken about shift tan, actually what that is that's the inverse of the function, and in maths we call that arctan. But regardless, on our calculators, we're just going to go shift tan. I'm going to go shift tan of 1, and so let me go to my calculator here. I'm going to go shift tan of 1. And what do I get? I get 45. And so I know that my angle is 45 degrees. And that makes all sense because the gradient of 1 means it's going up as much as it's going across, which would create, let's draw that, if it's going up 2 and it's going across 2, what sort of triangle have I created there? A right angle triangle which is isosceles, which is going to be 45 and 45. Wonderful. Okay, let's move to the next question. The next question says, determine the angle theta, this angle there, all right, in the sketch below between the two lines y equals a half x plus 3 and y equals negative x plus 4. Now, this is as complicated as these questions can get with the angle of inclination. This is where we need to be really switched on, all right? How are we going to do this? How am I going to solve for that angle? Well, what if I did this? What if I calculated the angle of inclination of the line going down? This line going down, I calculated that angle there, because I can do that. And I work out the angle of the inclination of the line going up, right? I can do that. We've discussed that. We know how to do that now. If I have the angle alpha and beta, the two angles of inclination, what am I left with? Have I not got that? All right. Can't I solve for this sketch geometrically? Does everybody see here that if this, let's give these random values, if this was 30 and this was 120, it would be quite easy to calculate what theta is. I can go and work out that this angle is 60 using angles on straight line, all right? And then I can just go and, because I know that all the angles in a triangle add up to 180, I can go say theta is equal to 180 minus 30 minus 60. And I can work out what theta is. Alternatively, and this is what I would prefer you guys to do, but either way it's going to get you to the answer, is does everybody see that alpha is the exterior angle of this triangle? And so what do I know? That beta plus theta is equal to alpha. Oh, I put in two pluses there. Let me take that out. And so I can say that theta is equal to alpha minus beta. All right? We've spoken a lot. But the point of this is that if they want an angle between two lines, what am I going to do? I'm going to find the angle of inclination of the one line, angle of inclination of the other line, and then I'm going to use geometry, normal geometry, to go find the angle that they want me to find. All right, so let's actually do this question now. All right, I've shifted the sketch to the top here so that I've got more space to work. I'm going to work out alpha, I'm going to work out beta, and then with geometry, I'm going to work out what theta is. Excellent. So let's start with alpha. Whenever I'm working out the angle of inclination, what am I going to do? I'm going to use this formula, tan alpha, tan of the angle is equal to the gradient. Now, the gradient of this line is minus 1. And so I'm going to get tan theta equals minus 1. All right. I'm going to put that into my calculator. All right. And I'm going to get theta equals, and let's go do that in our calculator. Oh, sorry. There. I'm going to go shift tan of minus 1. And I get an answer of minus 45. Now, we discussed this earlier in the lesson. I can't get an angle, a negative angle. And so what are we always going to do when we get a negative angle is all we're going to do is we're going to add 180. And so I'm going to take that minus 45. I'm going to add 180. And I'm going to get an angle of 135. I know that this angle alpha is equal to 135. Excellent. I'm halfway there. And if I can calculate beta, I can hopefully calculate what theta is. Excellent. So let's look at beta. I know that beta is the angle of inclination of my line going up. And so I'm going to go and I'm going to write tan beta is equal to m. This is the formula from the formula sheet for the angle of inclination. I know the gradient of the line going up. Well, is going to be the number that I'm multiplying x by, which in this case is a half. And so I'm going to go and say tan beta is equal to a half. Now I need to calculate what beta is, and so I'm going to go and use shift tan on my calculator. So let me go to my calculator. If I go shift tan of 1 over 2, what do I get? I get 26,57. Remember, we rounded up for that when we did this last time. So I'm going to get 26,57. Excellent. So now I know that this angle is 26,57. And what did we decide? Is that if I know, and let me write my two angles in there, 135 and 26,57. This is 135. This is 26,57. All right. Because theta is inside the triangle and beta is inside the triangle, I can say the two interior angles sum to the exterior angle of my triangle. And that's sort of exactly what we're going to do here. Is we've simplified this already, but theta is equal to 135 minus 26,57. I'm going to do that on my calculator to make sure that I get this right. I'm going to get 135 minus 26,57. And if I do that, I'm going to press SD there because I want a decimal answer. I'm going to get 108,43. So what do I know is that that angle there, theta, or what did we say it was? 108,43 is 108,43 in the center. So whenever we have an angle between two lines, always what I'm going to do is work out the angle of inclination of the one line, work out the angle of inclination of the other line, and then use geometry to solve for the angle that they want me to solve. Excellent. It's been wonderful. Thank you for spending this time with me. I will see you guys next time. Good luck with your maths, and goodbye.